This video is a demonstration of the Victorian Residential Efficiency Scorecard tool. The scorecard provides an energy rating of a home based on the design and construction of the home and its fixed appliances. This means that you can compare ratings between homes and trust that the results represent the fixed features of your home, the things that drive your energy bills. To maintain quality, the use of the scorecard tool is restricted to trained assessors who have met the accreditation requirements and have undertaken scorecard training. This video will guide you through the various steps involved in using the tool. An example home has been selected as a starting point. The data entry for the tool consists firstly of the customer's information, their name, address, contact details and phone number, and secondly, of information about the house. For example, the year of construction of the house is important because that affects the way we consider the air leakage of the building. Entering the postcode of the house determines its location and applicable climate zone. Under the Assessment tab, there's some fixed information about the assessment and an entry to select the number of stories of the house. After entering the basic data of the home, the next thing the tool will consider is fixed appliances, heating, cooling, and hot water. Heating appliances are added under the Heating tab. You can have multiple heating appliances, and there's a long list of different heating appliance types. In this case, we have selected natural gas ducted heating. For each heating type, there's a star rating, if that type of heating has a star rating, and also a year of purchase. The year of purchase is used because sometimes the star ratings have changed over time. Also, for ducted heaters, the year of purchase gives an indication of the performance of the ductwork. The same is true of cooling appliances. In this case, we have selected evaporative cooling from the list of types of cooling and the year of purchase. Again, with hot water services, there are many types of systems. Here we've selected a natural gas storage system and the star rating of that heater. We also have an indication of whether that hot water service is solar heated or not. For each kind of appliance, you can have multiple types. So for instance, we could add another heater which could potentially be used in another room. We'll demonstrate how the room allocations work later in this tutorial. The core of the scorecard tool is based on zones. Each room is entered as a zone, and then the parameters of that zone are entered in here. Each zone first considers the roof and ceiling. So we select the insulation level from the drop-down list of insulation levels. The next parameter is what's located above the room. For example, is it open air or another apartment? Is it an unconditioned room in the same house or a conditioned room in the same house? The same applies to the floor, selecting the floor type, timber, concrete slab or suspended slab. The floor insulation, what's below the floor area and the floor covering are considered. The next element is windows. Each zone can have multiple windows. For each window we note the window height and width, the frame material from a list of available materials, the orientation, the type of glazing, single, toned, double or low E high performance glazing, the overhang or eave depth of this window, and whether the eave is permanent or adjustable. Next, we select the curtains from the different types, from Venetian blinds through to heavy drapes and palmets. There's also an indication if there is an external blind on the window. So in this room, we have 3 windows, some facing north, some facing east, and where necessary, we can add more windows. The next element is the walls. For the walls, we are interested in the external wall material from a long list of available wall types and the level of insulation in the wall. In this case, it's brick veneer with foil insulation. We will also need to consider the quantity of shared external walls. For example, in a flat, there may be shared walls with another apartment. In this case, it's a freestanding house, so there are no shared walls. And then we will also consider the ceiling height of the zone at the external wall. In this zone, we've added the gas ducted heating from earlier, so that has been selected in this zone. If there are multiple heaters, then we could show that in this zone we had multiple heaters. In this sample home, we only have one heater. The same applies to cooling. In this zone, we've selected a ducted evaporative cooler. Next, we consider downlights. To save time, only halogen-type downlights are counted and noted here. The tool assumes that all lighting in the house is otherwise provided by energy-efficient, compact fluorescent or LED fixtures. The impact of the halogens here is threefold. Firstly, the energy consumption of the halogens. Secondly, the insulation displacement. Where a halogen is in a room with an insulated ceiling, it's assumed that the insulation was displaced because of the gap you need to put around a halogen downlight in a ceiling space. And finally, the air leakage is assessed. In this case, we have 6 sealed halogens, and the alternatives are minimal air leakage or large air leakage. We have one type of non-halogen lamp that has a large air leakage fitting. The next factor is air leakage. We consider the following: whether it has exhaust fans. This is the living room, so there are no exhaust fans. There are options for a chimney with a damper, or a permanently blocked chimney. The number of external doors in this zone, random holes and cracks which are common in older houses. If the zone has wall or ceiling vents, again, they're more common in older houses. Weather stripping. Are any external doors weather stripped? Are the windows weather stripped? Skirting boards and floorboard gaps? And are there any vented skylights? So now we have multiple zones, each with its own set of information. If we add a new zone, then some of the information for that zone is copied from the previous zone. For example, here the tool has added the same type of ceiling insulation and sharing aspect of the space above, along with the type of flooring. However, it hasn't added the floor area. This helps to reduce the amount of data entry because often the information is shared across zones. With water, we measure the flow rate of showers to determine the water consumption from a hot water system. This is done with a bucket and a timer test. So we place a bucket underneath the shower head, turn it on, and see how long it takes to fill. This shower runs at 12 litres per minute. The other feature to note are pools and spas. In this case, we don't have a pool or spa in this home. A spa means an outdoor heated spa, and with pools, we are interested in the type of heating for that pool: natural gas, LP gas, or solar, and what type of chlorinator it is. Saltwater chlorinators use energy. The last element is the renewable energy. We don't have one in this home, but we can have a renewable energy system, a photovoltaic system with a size option. We now save the data and then look at the output of the tool. We are able to preview the scorecard certificate, which gives information about the address of the house area, how much of that house is heated and how much is cooled. This is important because some homes will have smaller areas that are heated and cooled. The certificate also includes the date, assessment number, the assessor ID and name. The Scorecard star rating reflects the cost of running the fixed appliances in a home. A high star rating means the home will use less energy and costs less to run than one with a lower star rating. The rating is on a basis of 1 to 10 stars. This house has a low efficiency, so it's rated 3 stars out of 10. We anticipate that this will be the average rating for houses across Victoria. The next section shows the relative amount of energy that's being used by the different features of the home. So heating is more than half of the consumption of the fixed elements of the home. Note that the scorecard only considers the fixed elements, so it's not concerned with items such as fridges and televisions. Rather, the relevant features are heating and cooling, lighting and hot water. So in this case, heating is 51% and cooling is 6%, which is relatively low as evaporative coolers are quite efficient. Lighting is relatively high in this case, as there are a number of halogens in this home. Hot water is high. We don't have a photovoltaic PV system in this case. Otherwise, the tool would show the percentage of fixed appliance energy cost that were offset by the generation from the PV system. The next section of the report shows the hot weather rating. This is a rating from not easy to very easy of how your home would perform in a period of extremely hot weather and whether it would be comfortable or not very comfortable. This rating is based on how the home performs without cooling. In this case, it's 2 out of 5, so it's not a particularly comfortable home in hot weather if the evaporative cooler isn't working. The tool also provides improvement options for the householder to consider that will help improve a home's hot weather performance. For example, improving ceiling and wall insulation and installing blinds on the east and west facing windows would help improve this home's hot weather rating. The next section shows the performance of the different elements of the home compared to others of the same type. In this case, the building shell is roughly in the middle ground of efficiency. The building shell considers things like the wall material, floor material, windows and curtains. It includes improvement options, installing insulation in the ceilings and walls, and installing double-glazed windows in this case. The next element is the heating. This ducted heater, again, is rated as middle performance. To improve, the householder could consider installing a new high-efficiency gas ducted furnace or a reverse cycle system, upgrading the ductwork or replacing it with high-efficiency gas or reverse cycle space heaters. The evaporative cooler, in this case, is very high efficiency, so there are no improvements needed. The lighting is rated as middle performance. This home currently has a number of halogens installed, and the improvement options are to replace those with LEDs. The hot water service in this case is again in the middle range for efficiency on the scale of 1 to 5. Improvements here would be to replace the shower heads with high-performance shower heads and upgrade the hot water system to a more efficient system. With renewable energy, we don't have a photovoltaic PV system in this home, but we could install one to improve the scorecard assessment. After previewing the certificate, the assessor is able to finalise the assessment and email a PDF file of the certificate to the householder or send them a printed copy. For any further queries regarding the Scorecard program, please visit victorianenergysaver.vic.gov.au.